All right, example 4, compute the derivative of h of sine of x at x equals pi over 6, assuming that h prime of a half is 10. So if we want to know the derivative of h, so we can go ahead and say ddx of h of sine of x. That's a chain rule. So derivative of h, leave the inside sine of x alone, multiply by the derivative of sine of x, which is cosine of x. So now, if we want this expression at x equals pi over 6, this would be h prime of sine of pi over 6. Sine of pi over 6 is a half. Cosine of pi over 6 is root 3 over 2. And we're told that h prime of a half is 10. So this would be 5 square roots of 3 after the 1 half and 10 reduce. Example 5, determine dy dx if y is equal to this. So again, getting a little practice with this notation, Leibniz notation, dy dx. We will bring the 9 down. Subtract 1, there's our derivative of the outside. We're going to leave the inside alone by just rewriting everything verbatim. And then we will multiply by the derivative of the inside. Now remember here that this term here, cosine cubed of x, is really just cosine of x cubed. So the derivative of something like this is another chain rule, which would be 3 cosine x squared times the derivative of cosine, which is negative sine. We can clean this up by writing this as negative 3 cosine squared x sine of x. So this would be negative 3 cosine squared x sine of x minus 3 sine of x plus 0, because the derivative of a constant is 0.